everyone, welcome to Mrs. Shin's class. Today we're going over gradient of a curve and equation of a tangent. Okay, so let's figure out how we calculated the gradient of a curve. So this is a parabola x squared equation. Alright, how can we find what the gradient is when x is 2? So for example, when x is 2, I can draw a tangent line. Okay, so I just need to find the gradient at when x is 2. Okay, we can use the gradient function to find out any gradient on the curve. So since we know that the y equation, original equation is x squared, if I differentiate it, it's going to be 2x. And the gradient when x is 2, okay, what am I doing here? The gradient when x is 2, I'm going to insert 2 in the equation. So 2 times 2 will be 4. So the gradient at this point will be 4. So this is how we could find out the gradient of a curve, right? And gradient, another mean, we could also written it as m. Remember this? Y equals mx plus c. The m value here was the gradient, so we can also write gradient equals to m, right? This was one way to find a line, equation of a line. Right, there was another way. It was this one. So if I know what the gradient is and x1, y1, just one coordinate that passes through the line, okay, then I can also generate this form to calculate the equation of tangent line. Alright, so to recap what we have done in the past years, let's have a go at doing those two questions. So number 1, I have the same equation, y equals x squared. I want you to find the gradient, this time when x is 3. So there you go. When x is 3, yep, I can draw a tangent line, okay? And I need to find the gradient. So gradient is from the original equation, I differentiated, which is the gradient function, right? So I can find the gradient equation. I can find any sort of gradient of the curve. This time I want to find the exact gradient when x is 3. So I'm going to insert x3 like this. Okay? And I can rewrite that m or gradient is equal to 6 when x value is 3. Okay, the next question, it says find the equation of the tangent. Find the equation, this line. Find this linear line when x is 3. Right, remember what was the rule? Okay, so let's have a go. Okay, I copy down the equation. What is my m? My m value is 6. And when x is 3, the corresponding y value, what would it be? I'm just going to insert 3 there into the original equation. 3 squared is 9. Okay, so this line passes through a point 3,9 and the gradient is 6. Okay, so I'm just going to insert those values. So this one is x1 and this value is y1. So y, I'm just going to rewrite it. Minus my y1 is 9 equals m is 6. X, right, x1, which is this one, 3. There you go, and I can just calculate the value like this, and I can simplify. There you go. So this will be the equation of the tangent of the red line. People, to find the gradient of the curve, there were two methods, which is this one and also that one. We could also use this one to calculate the equation of the tangent, which is linear in this case, right? So let's have a go. Calculating in this method, right? It's still the same, passing through this one point, and the gradient 6. So instead of y, it's going to be 9, like this. So m is 6, x is 3. So I'm just going to calculate this, rearrange to calculate the value of c, like this. And if you calculate it, it's going to be -9, isn't it? So we found out that c value is -9, so we just need to substitute back into this value so I can find the equation of the tangent. There you go. M is 6, c is -9. Ooh, either way, I get the same value, which is the equation of the tangent line when x is 3. So people, this is the revision from previous years, like year 11, and sometimes if you were early, you could have started this in year 10. So, yep, we already learned, and from previous years, we know how to find the gradient of a curve. We know how to find equation of tangent, right? Okay, let's go in a little bit deeper and say find the equation of the normal, okay, to the curve of x squared. So I want to find the normal when x is 3. So over here, this is the tangent equation to the curve. Tangent means it's touching one point, right? What's the normal to that? Okay, normal is basically you have a tangent at when x is 3, that's 90 degrees. Okay, so it's 90 degrees to the tangent curve. So the gradient of the tangent and the gradient of the normal is negative reciprocal to each other. So remember last year that we learnt m1 times m2. When you multiply the gradient of this and gradient of this becomes -1. Those two gradients meets in the right angle. Okay, remember when x is 3, the gradient of the tangent is 6, and it passed through 3, 9. So if I want to find out the gradient of the normal curve, okay, then this times whatever has to be -1. So therefore, if I rearrange, okay, the gradient of the normal should be -1 divided by 6. So -1/6. Or straight away, since those two are negative reciprocal to each other, reciprocal of this is 1/6. Because it's 6/1, right? Flip it. And negative reciprocal, so I'm just adding negative. So there you go, straight away. So since it's the gradient normal, okay, and it's also passing through 3, 9, as you can see over here, okay, we have the new equation, but same passing through the same point, 3, 9. Okay, you can use either of the equation, but this time I'll have a go at using this one. Or actually, I'll just use the second one because some people are not really familiar with this second equation. So I'll have a go with this one. So my y1, so I'm going to write y as it is. My y1 is what? 9. My m is -1/6. X, I'm just going to write it as it is. X1, what is it? 3. Yeah, so -3. So you just need to expand the bracket, rearrange to make it into this form. So there you go. That will be my equation of the normal to the curve x squared. Okay. Okay, now let's go into real year 13 math. Okay. This year, it's the concept is exactly the same, but it's ln. Or it will be square root or exponential functions, okay, or it could be like in fraction. Right, so what I need to do is it's telling us that gradient of the tangent to the curve at x equals 2 is 1. So gradient, it's just saying when you find gradient function and let x equals 2, then the gradient is 1. However, it's also including the unknown value k. So by doing that, okay, you could rearrange and find the value of the missing k. Okay, so shall we have a go? Okay, so if I want to differentiate it, what do I have to do? 1 over, okay, and the thing in the bracket, but I need to differentiate what's inside the bracket, which would be k, and I just need to multiply it on the side, right? Next one, if I want to differentiate the next term, it will be 2 down, so negative 2x. Okay, in the question it says when x is 2, my gradient is 1. This is my gradient function, so when x is 2, okay, in here instead of x, I'm going to put 2, right? 2 will be 4, and this, the gradient, is equivalent to 1, as it says in the question. Now, the question is now asking us to find the value of k. Oh, I think we can do it. I'm sending 4 away, just rearranging. Okay, fraction equal to fraction. This is again equivalent to 5 over 1, right? So when it's fraction equals to fraction, ka-ching, I can do cross multiplication. So those two multiplied on one side, the other two multiplied on the other side. Okay, like this. Right, I'm going to expand it out. Let all k's on the left-hand side, number on the right-hand side. Here you go. Okay, so I finally found out the value of k, which is 5 over 9. So it wasn't different at all, but when I'm differentiating it, it was including the ln, something new that was in year 13, right? So I differentiated ln, and what did I do? They told us when the x is 2, the gradient was 1. So that's how I substitute those values in. And there you go, just do the normal algebra and calculate the k value. Okay, this time I'm gonna have a go at doing another question that has exponential in it. Okay, so it says find the gradient of the tangent of this curve when x is 2. Okay, and this is the coordinate that's on the curve. Right, so first of all, I need to find the differential of this equation. So what would it be? Yep, so I differentiated 0.5 and multiplied on the side. Now I need to find the gradient when x is 2. So therefore, I just insert 2 in instead of the x. Okay, and if you put this in the calculator, it will be a very simple number, 5. Okay, now let's find the equation of the tangent. Okay, so finding the equation of the tangent, this is the form, right? The m is 5. Okay, x, y, I'm gonna write it down. What's my y1 and x1, which is this coordinate over here? So you can substitute the values like this. And let's rearrange and simplify the equation. If you do that, I'll get y equals 5x. Okay, and that will be the equation of the tangent to the curve when x is 2. Okay, this time, let's have a go at doing the equation with a sign in it. Again, I need to find the equation of the tangent, so therefore, I need to differentiate the original equation. Okay, in that case, my sign will be changed into cosine, and using the chain rule, I have to take this one outside and differentiate it and multiply it, right? So simplifying would give 8 cosine 2x, okay? Right, next is finding the equation of the tangent, okay? If you want to substitute those values, we know that we need the m value and a coordinate that passes through the equation, right? So obviously, what do we need to do? In here in the gradient function, I need to insert x equals pi over 6 to find out the gradient. So there you go. Instead of x, I just put pi over 6 pi over 6. Calculate this first, do the cosine, then times 8 to calculate the gradient. I get the simple answer, which is 4. So my m is 4. However, I only know that the x value is pi over 6, but I do not have the corresponding y value, right? So I need to calculate the corresponding y value by inserting this one back into the original equation and calculate the value y. Okay, like this. Okay, if you do that, I will get 3.46 as a corresponding y value when x is pi over 6. So this is x1 and this is y1. So there you go. I need to find the equation of the tangent, so I substitute those values in. So if I want to expand, rearrange, and calculate those values, there you go. I'll get the final answer. The equation of the tangent. Okay, so no matter whether your equation is an exponential function, or including the trig, including ln, or just a simple polynomial, it's exactly the same. Okay, so have a go, give it a go. Okay, it's exactly the same concept, just a little bit more difficult when you're doing the differentiation, right? Okay, so have a go at doing some more questions from the book. Otherwise, I'll see you in the next lesson. Bye bye.